You're most welcome once again to our videos. My name is still the same, it has never changed. And I'm here still to share with you some concepts in physics. And today I'm here to share with you a relationship between the period of revolution of satellites, of bodies, of planets around stars, around planets, moons around planets, stars around other stars in a given galaxy, and likewise also planets around stars that are close to us. For example, if you look at Earth, Earth revolves around the sun through 365 days, period of rotation around the sun. If you look at the moon goes around the sun, moon goes around the Earth around 27.3 days. Then other bodies also there, like satellites, they go around the Earth. There are those satellites in what we call parking orbits. Those ones also take a period of revolution of the Earth, which is approximately 24 hours. So there is a concept that brings about that time to be there. That time can be derived from what we call Newton's law of gravitation and the circular or the centripetal force experienced by these bodies. So today I want us to share with you the relationship between or derivation of period of a satellite from Newton's law of gravitation. So we need to first remind ourselves, what does Newton's law state? Newton's law states that the force of attraction is given by capital G, mass of the controlling body, the bigger body, times the smaller body, divided by the radius between the two bodies. Remember, we said that force of attraction is experienced by both bodies. I and you have that force experience between us, but the force is very small depending on the distance between us. But for these big terrestrial bodies, we see why they are in those positions they are in. It's because for them their force is a little bit bigger. So the moon can't run very far away from the sun, from the Earth. The Earth cannot run very far away from the sun because the force of attraction between the two is big enough. Now, secondly, we have what we call centripetal force. This is called the centripetal. The force this body is going to experience. This is a body of mass small m. This is the radius from the center of the bigger body of mass capital M. This is the orbit which our small m or our satellite or our moon is following as it rotates around, as it spins around the axis of what? Of the planet. Assuming this is the planet. And you have its moon somewhere around here. Its moon is revolving around it all the time, taking a period of whatever it is, 30 days, 365 days, 400 days, I don't know, whatever it is that is up there. As long as it's a terrestrial body revolving around any other terrestrial body, then it is experiencing Newton's law in terms of the force. It is experiencing a centripetal force. Now, at this instant, the centripetal force is provided by this electrostatic force of attraction between the two. So it means that the electrostatic force of attraction is going to provide us with a centripetal force. This force is due to the gravitational constant capital G. We have mentioned it in some of our videos. If you keep following us, you can check on some of these forces. If you've missed them, go back to the other videos, you'll find them. That means capital GM, small m out of the radius squared, is always giving us mv squared out of r, where v is the speed with which the satellite or the moon or the Earth revolves around the body that controls it. Earth is revolving around the sun. If yes, it means the Earth is being controlled by the sun, and that means the Earth is the smaller body this time round. The sun is the one with capital M, which is the bigger body. So if I lose the small m, we shall have capital GM out of r squared. I'll lose one r. When I lose one r with this one, I'll have v squared. But from circular motion, v is equal to omega r. So this is going to be omega squared r, which omega is the same as what? 2 pi f times r, the whole of it is squared. But also, frequency is the same as 1 out of the period. So therefore, with that, we shall have capital GM out of r is equal to 4 pi to the square over the period squared times the radius squared. It is from this note that when you cross multiply, we shall have the period squared times capital GM is equal to 4 pi to the square r to the cube. And therefore, I can estimate the period of revolution of planets around the suns or around their stars. I can estimate the period of revolution of moons around their planets which control them. I can estimate the period of the satellites around the planets which they revolve around. So period squared will therefore become 4 pi to the square r to the cube divided by capital GM. And it is from this note that you'll see period capital T as being given by 4 pi squared r cubed out of capital GM, the whole of this raised to the power half. Also, another relationship we can see from here is the T squared being directly proportional to, because this expression of pi, 4 pi squared over capital GM, the whole of it can be a constant k. Then you can say T squared is equal to k r cubed. Therefore, this deduces the law of Kepler, which law Kepler suggested, and he said that the square of the periods of revolution of the planets around the sun as one single focus is always directly proportional to the cube between the planets and the stars or and the sun. The same applies to other items. The square of the period of revolution of the moons from the what? From their controlling planets is directly proportional to the cube of the distance between the moon and the planet that is controlling it. So with that, I have deduced what we call the relationship or the period of the satellites or period of bodies, how it is dependent on the distance between these two bodies, in a sense that the distance is always directly proportional to the cube of the distance, the period squared is always directly proportional to the cube of the distance of separation of the two bodies, as the law was also suggested by Kepler. So you can be asked to use Newton's law to deduce Kepler's law. Newton's law is F is equal to capital GMM over R squared. It is from here that we came and arrived at period squared is directly proportional to the cube of the distance between the two terrestrial bodies. I'm still Hamza, and I would like to thank you once again for always liking and sharing our videos, for viewing our videos. Just hit on the subscribe button if you've not yet hit on it, and then make sure that everyone you know, every physicist that you know around there, around close to you, around your families, in your schools, in your former classes, in your classes, are all aware of such videos. Thank you so much. See you next time.